Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. In this video, I am going to explain to all of you about sound. And this video is recorded for the purpose of CSC253 course in UiTM. In this chapter, we are going to learn Introduction to Sound, Multimedia System Sound, Digital Audio, Midi Audio, and lastly, Digital versus Midi Audio. Okay, now let's discuss about the first issue in this topic, that is the introduction to sound. When we talk about sound or audio, we can say that sound perhaps is the most essential or the most important element of multimedia. In multimedia, we use sound to deliver meaningful speech, to play music, or to give a special effect. In other words, we use sound to attract attention, okay, to convey an idea through the speech, okay, to elicit an emotion. For example, we use sad music to deliver sad situation or the sad scene, okay, and then we also use sound to dramatize point. For example, we use the sound of ringing bell like ting ting for ideas and so on. Okay, now, how can a human like us can hear sound? Basically, we can hear the sound when the sound wave is produced. So, how can the sound wave is produced? We can say that the sound is a type of energy made vibrations, okay, getaran. So, when an object is vibrated, it causes the movement of the air molecules. Okay, so apabila satu-satu objek dia ada movement ataupun bergerak, maka molekul-molekul di dalam udara tu akan bergetar lah. Maka apabila dia bergetar, maka getaran itu akan menghasilkan wave. So, when the wave is produced, okay, macam mana dia produce tu, iaitu kan dalam udara ada banyak molekul. So, every single molekul yang ada dalam udara akan bertembung di antara satu sama lain dan dia akan menyebabkan berlakunya wave, ataupun kita boleh gambarkan when we throw a pebble into a still water. Okay, into a still water. Okay, jadi bila kita masukkan pebble ataupun batu kecil ke dalam still water, dan getaran akan berlaku, jadi kita akan boleh nampak wave di dalam air tersebut. So itu adalah analogi lah. Jadi daripada analogi tersebut, kita boleh nampak bahawa ada wave di dalam air tersebut. Okey, pada air tersebut berlaku wave. So sama juga apabila berlaku getaran pada objek, jadi molekul-molekul di dalam udara akan bergetar seperti wave itu juga, tapi oleh kerana benda tu adalah udara, jadi kita tak nampak lah. Alright, then the wave hit our ears. Okay, the wave hits ataupun it vibrates our eardrum. Jadi dia kena pada eardrum kita, and then eardrum akan hantar wave tersebut kepada ear bones kita lah yang ada di belakang telinga kita, and then the ear bones is used to amplify ataupun menguatkan the wave. Alright, and then the wave is sent to ataupun it is converted into impulses in the cochlea. And then kat situlah berlakunya apabila diterjemahkan oleh otak. Okay, it is interpreted by our brain, dan kita tahulah benda tu adalah sesuatu bunyi. So basically all of this thing has been taught by your teachers in your secondary or maybe your primary school. Okay, now we are talking about frequency of pitch, acoustics, and also the decibels. First of all, we take a look into frequency or pitch. Okay, frequency is also known as the pitch. Okay, so what is frequency? So frequency is the number of time per second, okay, the number of time per second that a sound pressure wave repeat itself. Meaning that frequency representing how many waves, okay, how many waves of the sound in 1 second. Okay, so itu adalah frequency. Okay, in 1 second. Okay, the higher frequency, it is not the loud, but the more irritated our ear will be. Okay, so the lower frequency, then less irritated it will be. Okay, for example, if we hear a drum sound and also a whistle sound. Okay, when we hear a drum sound, so we feel less irritated rather than we hear a whistle sound. Okay, so bila kita dengar whistle, telinga kita akan jadi lebih sakit compared to we listen to the drum. So meaning that the whistle has higher frequency, ataupun di dalam satu saat bunyi whistle tu terlalu banyak gelombang. Okay, there is many waves. Okay, there are many waves in 1 second apabila kita meniup whistle. Tetapi nak bandingkan dengan drum, okay, in 1 second nilai frekuensi ataupun nilai wave yang terdapat di dalam satu saat untuk drum tu adalah lebih sedikit. That is why bila kita dengar bunyi drum, kita tak rasa sakit telinga sangat berbanding apabila kita mendengar bunyi whistle. Okay, the unit for measuring frequency is called hertz. Okay, H-E-R-T-Z, hertz or Hz. Okay, so human with a normal hearing can hear the sound between 20 Hz to 20,000 Hz. Okay, so the frequency above ataupun more than 20,000 Hz are known as ultrasound, which is we cannot hear the ultrasound. Okay, in contrary, the sound that is below than 20 Hz is known as infrasound. Okay, so below than 20 Hz, we know as infrasound. Higher than 20,000 Hz is known as ultrasound. Both ultra and infrasound cannot be heard by human. Okay, so basically the ultrasound can be heard by the animal like dog and also bats. Okay, so dog can hear the sound as high as 45,000 Hz, and bats, okay, kelawar, can hear up to 100,000 Hz. Okay, next we discuss about acoustics. So what is acoustics? Acoustics is the branch of physics that studies sound. And the people who studies acoustic is known as acoustician. There are lots of things to be studied in acoustics. Okay, for example, acoustic resources, that is what are the physical resources of sound, okay, what produces sound, okay, and then acoustic environment, which mean how the environment or the area will be manipulated to produce sound or to control the sound and so on. So the study in acoustics or the study of sound is very important in our life. Okay, for example, we use sound or acoustics field to find the oil and gas, okay, in the deep sea. All right, we use the ultrasound or whatsoever to find the oil and gas. Also, we use sound to study the earthquakes, okay, the climate change, and also we use the ultrasound, okay, for the pregnant woman, okay, to check the baby's condition in the womb. All right, so there are lots of use of sound in our daily life. And next, let's just discuss about the decibels. Okay, so decibels is the unit that is used to measure the amplitude. So what is amplitude? Amplitude is the relative strength of sound wave. Okay, so the relative strength of the sound wave akan memberi effect to the sound loudness ataupun volume lah. Alright, so that's why we measure the loudness ataupun the volume of a sound in decibel, dB. Okay, so basically decibels akan ataupun amplitude akan jadi kuat, okay, apabila wave-nya kuat. Okay, so kita pun akan dengar bunyi tu dengan kuat. Jadi apabila decibel ataupun amplitude-nya makin menurun, okay, the less decibel, then the volume will be lower lah. Kita akan dengar volume tu dengan perlahan. That is why contohnya kalau kita duduk bercakap dengan orang yang sangat jauh, maka orang yang bercakap tu wave yang keluar daripada mulut dia tu pada asalnya adalah sangat kuat. Okay, the strength is very high apabila keluar daripada mulut dia. Tetapi apabila dia berjalan apabila wave tu berjalan through the air untuk sampai kepada kita yang duduk sangat jauh ni, wave tu akan jadi makin lemah. Okay, wave tu akan jadi makin lemah, maka oleh itu kita akan dengar suaranya tu dengan perlahan. So conclusion, the higher the decibel or the higher amplitude, then the louder we will hear something. Alright? Okay, so why we need the sound? Okay, why the sound is very important. So first of all, okay, we need the sound, especially in multimedia, to set the mood. Okay, to set the mood, whether this multimedia is for fun, this multimedia is serious content, this multimedia is religious content or whatsoever, and then also to catch the interest. Okay, to catch the interest, and then we also use the sound to alert the audience. And lastly, we use the sound as the narration sound or the narration speech. Okay, now we discuss about the multimedia system sound. So multimedia system sound is the sound used by the computer system. Okay, not used by the user lah. Okay, iaitu all the sound that the computer system ataupun OS yang gunakanlah, operating system yang menggunakannya. Okay, for example, if we did some error, then akan keluar satu bunyi yang menunjukkan okay, we did the error. Alright, so itu adalah system sound. Okay, so we use the system sound for the startup, okay, and also the warning. Both Macintosh and also Windows have their own system sound. For example, in Macintosh, they provide system sounds such as the glass sound, the indigo sound, the laugh sound. Okay, and for Windows, for example, they have start, wave, chimes, and also chord. For the multimedia use or the multimedia purpose sound, okay, we normally digitally recorded the audio, or we use the Midi or musical instrument digital interface music or sound, okay, to be used in the multimedia. So later on, we discuss more about the digital audio and also the Midi audio. Okay, next let us discuss about the two types of audio. Those are digital audio and Midi audio. Okay, so first of all, let us discuss more about the digital audio. So digital audio is the actual representation of sound, or it is the actual representation of any sound, but it is only stored in the form of samples or in the form of digital. So maybe there is a question about what are the differences between analog and the digital audio. So basically there is no huge difference, okay, only the difference is how the digital and analog sound is stored. Okay, so analog sound is stored in the analog devices such as radio tape, okay, or the phonograph record ataupun apa yang kita panggil piring hitam, okay. Digital sound pula disimpan di dalam digital devices lah, okay, and it is stored digitally. Okay, so dia dah digitalize kan, so dia akan disimpan dalam bentuk digital. So macam mana dia simpan dalam bentuk digital? It is transform, okay. The sound wave tu tadi, it's transformed into sound samples. So dalam bentuk digital ada sound wave tak? Tak ada sound wave, tetapi ada sound sample. Okay, so maybe there is also another question. So what is the sample in digital audio? Yang kita dah sebut-sebut sample tu. Okay, so we can say that sample is the wave. In analog, it is the sound wave. But when we transform the analog audio to digital audio, the wave become samples. Okay, the wave become sample. So sample is representing the amplitude. Amplitude tadi apa? The loudness ataupun the volume level of the sound. Okay, so the sample represent the amplitude or the loudness of the sound at a discrete point in time. So in digital audio, the quality of the sound is depend on the sampling rate dan juga sampling size. So sampling rate adalah frekuensi. Okay, so in analog kita panggil dia frekuensi, but in digital we call it as sampling rate. Okay, frekuensi tadi tu maknanya ada berapa banyak wave dalam satu saat. So now bila kita sebut dalam sampling rate, so ada berapa banyak sample in 1 second. Okay, so sampling rate is the number of samples taken per second. So sampling rate also is measured as same as the frequency, iaitu in hertz. Okay, so bila dah masuk ke dalam digital ni biasanya kita akan simplifykan lah the units tu. Okay, kita tak sebutlah 20,000 hertz. Okay, normally kita akan sebutlah 20 kilohertz. So macam tu lah. Okay, so kita gunakan measurement of kilohertz to measure the sampling rate. Okay, for example, kita ada 22 kilohertz, meaning that there are 22,000 samples in 1 second, ataupun kalau kita dalam bentuk analognya ada 22,000 kilohertz frequency in 1 second. Okay, now what about the sample size? Okay, sample size is the resolution ataupun kita panggil the bit depth ataupun dynamic range. Okay, that is how many numbers are used to represent the value of each sample. Okay, macam mana pula sample rate ni kita nak tengok? Okay, bandingkan ataupun ingat balik semasa kita belajar image. Okay, saya ada tunjuk berkenaan dengan bit rate. Okay, lagi tinggi bit rate-nya maka lagi banyak warna boleh disimpan. Okay, so kalau kita hanya ada 1 bit maka hanya ada 2 warna boleh disimpan. Kalau kita ada 2 bit, maka ada 4 warna boleh disimpan. Kalau kita ada 3 bit, maka kita ada 8 warna boleh disimpan dan seterusnya lah. Okey, jadi lagi banyak bit, maka lagi banyak warna boleh disimpan. So itu analoginya. So sample rate ni pun sama jugalah, iaitu berapa banyak, berapa banyak bunyi boleh disimpan. Okay, so lagi banyak bit, maka lagi banyak sampel yang boleh disimpan. Jadi kalau kita ada 16 bit, okay, kita ada 16 bit, meaning that kita boleh simpan sehingga around 65,536 sample size ataupun samples je lah. Okay, so lagi banyak bit ataupun lagi tinggi bitnya ataupun sample size, so lagi banyak sound yang kita boleh simpan lah. Okay, so bandingkan dengan analogi image yang baru ni tu. Digital audio is known as device independent audio because of the quality of the sound or the quality of the audio is depending on the quality of recording device. And the quality is not depending on the playing device. Okay, so maknanya if you record on a very high quality recording device, then your sound is full of quality lah. Okay, tak kira lah play dekat mana-mana pun. But if your recording device is in low quality, then kita play lah dekat high tech device pun, kita kena kata bahawa that audio has a very bad quality because of the recording devices is in low quality. Okay, now what about the quantization? Okay, so basically, quantization is the process of converting the analog wave, into the discrete value or into the digital value. Okay, so quantization is the process of converting the analog audio into the digital audio. So as you can see in the chart in this slide, at the quantization sample there, The blue lines represent the true signal or the analog signal lah. And the green lines represent the quantized signal or the digital signal that has been transformed based on the audio signal. So how they transform the analog into the digital? Okay, so basically dibuat macam ni lah. Okay, kita ada satu wave, okay, yang the blue color tu, okay, itu adalah wave yang asal. Maka bila nak masukkan ke dalam digital form, okay, so dia akan quantizekan ataupun dia akan plotkan titik-titik tertentu, okay, supaya komputer boleh mengenali titik-titik itu dan dia akan simpan semua titik-titik yang ada yang telah diplotkan dalam bentuk digital. Bentuk digital tu maksudnya bentuk 0 and 1 lah. Okay, dia boleh simpan dalam bentuk data. Sebab komputer tak boleh simpan data dalam bentuk wave. Dia hanya boleh simpan data dalam bentuk digital. So that's why as you can see on the screen, okay, yang dalam bentuk warna hijau tu dia berbentuk garisan yang lurus lah. Okay, garisan lurus melintang dan garisan lurus yang menegak. So garisan-garisan lurus itu menandakan sama ada dia berada pada digit 1 ataupun digit 0. Okey, so untuk sekarang ni itu sajalah yang perlu awak tahu. Kita tak perlu tahu this quantization in a very deep explanation. So apabila wave sound tadi itu telah pun di-quantizekan, okey, maka dia akan disimpan di dalam komputer dalam bentuk digital tadi kan. Jadi the range of amplitudes ataupun yang disimpan tadi itu dia akan disimpan berdasarkan bit depths. Okey, bit depths tadi itu yang dalam previous slide. Okey, dia akan disimpan dalam komputer mengikut bit depths ataupun size resolution dia lah. Okey, mungkin for example if the computer have 8-bit quantization, okey, maknanya kita boleh simpan dia in 256 different values. Okay, ataupun different kind of plot ataupun different kind of sound lah. Okay, but if the computer have 16-bit quantization, then the possible values yang ada yang kita boleh simpan adalah ataupun the possible different sound yang kita boleh simpan adalah lebih kurang sebanyak 65,536 possible values. In the process of producing the digital audio, you are also required to balance the quality of the audio and also the memory and hard disk capacity that you have. Okay, if you have a large capacity of memory and hard disk, then you can produce a very good quality of sound. Okay, and also you can produce a very high quality of sound and also with a clean recording setting. Okay, so contohnya if you want to record something, then you record in a studio. So kat situ ada soundproof and so on. Jadi tak adalah ada noise yang lain-lain. For example, mungkin dalam video ni awak dengar ada bunyi ayam lah. Okay, so itu adalah satu situation tempat recording yang kita kata kita tak clean lah, because my house is not a recording studio, so kita tak adalah nak kata soundproof and so on. So ayam jiran sebelah pun bunyi dan akan masuk dalam kita punya recording. So kita boleh kata yang saya punya recording is not a very high quality because ada banyak noise. So now we are talking about mono and stereo audio. Okay, or we are also will discuss about mono recording and also the stereo recording. Okay, so what is mono audio or mono recording? So in mono audio, meaning that we deliver the audio in one channel, in a single channel. Okay, in mono recording, meaning that we capture the sound by using a single source or by using only one microphone. Okay, in stereo recording, we capture a single sound source or multiple sound sources with two microphones. But in mono, we only use one single microphone. Okay, when we record an audio in a mono recording, okay, but we play back, the audio by using stereo or two channels. We call it as dual mono, where the dual mono, the mono recording, okay, the single channel recording tadi tu is played back equally in the two channels, okay, basically in the left and also in the right speakers. Okay, so kita nak senang kata stereo ni dia ada dua channels. So basically kalau nak menyampaikan stereo audio, we must have two speakers, okay. In order to record the stereo audio, we must use two microphones. Macam itulah. So as you can see on the screen, okay, there are two types of formulas. Okay, so formula ni kita gunakan untuk tahu berapakah size recording untuk mono recording dan juga stereo recording lah. Alright, so these are the formula untuk kita kira where mono digital recording is equal to sampling rate times with duration of recording in seconds, and we multiply it with bit resolution over 8, and we times it 1. Why we multiply with 1? Because it is mono. Okay, so bezanya dengan stereo adalah stereo, okay, the last step is we'll multiply with 2 because there are two channels in stereo. Please do some exercises from your notes or in the textbook about this, okay, because there are always questions on this calculation for this topic. Okay, now we move to the sound editing part. Okay, so the first editing operation that we can do is the trimming. Okay, trimming means we remove some dead air or any blank spaces that we don't want, or we can trim any parts of the sound that we don't want to be included. Okay, second, the splicing and assembly, where we use the same tool in the trimming, but maybe we trim or we cut in the middle of the audio, and then we assemble the audio after we finish cutting. Okay, next is the volume adjustment, okay, where we adjust the value of the volume, okay, whether we want to make it louder or we want to make it softer. Working on multiple tracks is about to do the job or to do the editing task on more than one tracks. Okay, maybe we have two tracks, okay, for example the speech tracks and also the background music tracks, and then we want to combine all the tracks, both two tracks, into one sound. So that is working on multiple tracks. Next is the time stretching editing. So by using the time stretching, it is the advanced program that lets you alter the length of the sound. Okay, alter the length of the sound without changing the pitch atau without damaging the audio lah. Okay, and then next is the format conversion. Okay, in format conversion, okay, you can convert the format of the audio, for example daripada wave format kepada MP3 and so on lah. You are also resampling or downsampling by doing the format conversion. Okay, for example, wave sample ni sangat tinggi ataupun size ni sangat besar. When you convert into MP3, meaning that you have downsampled. Okay, you have downsampled ataupun awak dah kecilkan the size of the sound. Next, if you are working with sound, you can do fade in and fade out, especially in the beginning and also in the ending of the sound. Okay, it is good to do fade in and fade out because we don't want the sound to be ended in sudden. Equalization pula is the editing task that you can do so that you can make the sound brighter or darker. And lastly, there is also the digital signal processing, where I can say that I can give you the analogy of giving filter to a picture. Okay, the same thing that you can give to the same thing that you can do on the sound, where you give filter to the sound. Okay, for example, you give the sound the filter or the effect of chorus. Okay, sebenarnya pada asalnya suara tu tak ada chorus, tapi kita letak the effect ataupun the filter of chorus, then akhirnya kita boleh dengar suara tu in a chorus effect. Okay, so these are all the editing features or the editing tasks that you can do on the digital audio. Okay, so next we are going to discuss about the Midi audio. So Midi is a sound type that is stored in the computer or digitally stored in a numeric form. Okay, but it is not a digitized sound. Digitized sound is made from or is recorded from the real sound. Okay, digitized sound is made or is recorded from the real sound, from the analog sound, but Midi is produced solely by using numeric form, ataupun kita boleh kata solely from the digital world lah. Okay, so but it is not a digital sound. Okay, please remember that digital sound itu adalah sound yang dalam bentuk analog tetapi disimpan di dalam bentuk digital. Midi tak. Midi dah memang asal-asalnya dalam bentuk numeric. Bila sebut numeric maksudnya dalam bentuk coding lah, kita boleh kata macam tu. Okay, macam nak buat Midi? Okay, we need a sequencer software and also a sound synthesizer in order to create the Midi scores. Okay, so Midi is a device dependent. Okay, so device dependent means quality of the audio is depends on the playback device. Okay, sebab dia tak ada recorded devices. Okay, dia tak ada recording devices, so dia hanya ada playback devices. So the quality of the Midi sound is depending on the the playback device. Okay, jadi kalau playback device tu adalah yang kena dengan Midi yang high quality, then the sound will be the sound that is produced is in high quality lah. If not, then the sound will be like in low quality. The size of Midi file is very small compared to the digitized audio. Okay, because it is only the numbers. Okay, it is the numbers. So the length of Midi can be changed without affecting the pitch of the music. Okay, so kita nak panjangkan satu-satu note tu ataupun kita nak pendekkan satu-satu note, so the quality of the audio won't be affected. Okay, so itu adalah kelebihan Midi. Okay, and that is why when you are working with Midi, okay, you are required to have the basic ataupun kena tahulah, okay, sedikit about the music theory, because apabila kita bekerja dengan Midi, okay, kita akan bekerja dengan the music score, okay, ataupun note-note music itulah. Jadi kalau orang yang tak tahu music score, okay, orang tak tahu, okay, A bunyi macam mana, B bunyi macam mana dan sebagainya, so akan menyukarkanlah. Okay, just like me, saya tak tahu pasal music, so I cannot use Midi audio. Lastly, we are going to discuss about the digital audio versus Midi audio. So first of all, the analogies ataupun the analogy of digital audio is bitmap images. Okay, yang mana kalau bitmap images, kalau kita capture, we capture it from the real world situation, the real world picture. Okay, so digital audio is we record it from the real sound. Okay, the real world sound. Okay, so the analogy for the Midi audio is the vector image. Okay, where vector image maknanya dia terdiri daripada titik-titik garisan sahaja. So Midi pula terdiri daripada nombor-nombor yang telah diplotkan lah di dalam score music. Okay, so the dependency. Okay, so digital audio is device independence, where it depends on the recording device Okay, the quality depends on the recording device, not on the playback device. But the MIDI audio is device dependent, where it depends on the quality audio. Okay, the quality of the audio depends on the playback device. Okay, so what about the file size? Of course, the digital audio is bigger size, and MIDI audio has the smaller size. Okay, about the quality, okay, the less quality if downsampled. Okay, if you downsample the digital audio, then the quality will be less. But if we stretch out or stretch in the MIDI audio, the quality of MIDI audio is still remain. Okay class, so I think I have explained everything about sound, everything that is important. So anything that I have not touched in this video, please refer and read your note and also your textbook. Okay, so until we meet again in other videos, thank you so much. Bye bye.